This is video 10C. We're going to be following module 19-3 of your textbook, and this is the surface area of pyramids and cones video. So our essential question is, how can we always relate what we know now to what we knew before to develop a new surface area formula here? It's very similar to what we've done as far as surface area for prisms and cylinders. So when we talk about, first of all, pyramids, a regular pyramid is a regular polygon base, and then the lateral faces are, of course, congruent isosceles triangles. So you can see as we unfold here the net of all these triangles on the pyramid that are completing this figure by putting the dimensions in is just going to be simply, I'm going to zoom in a little bit, the square base or the regular quadrilateral base on the side there are going to have S as sides all the way across. And you can see that the perpendicular height, it's drawn in, but I'll draw it in another time, is the same as the slant height. That's if I were to draw on the outside of the pyramid, the slant height. So if we write an expression for the length of that big rectangle up there, we're going to get 4S. Question C, how does this length of the rectangle compare to P, which is the perimeter? Well, perimeter is the same as 4S, so that's exciting. When we get to D, now we're going to take, instead of putting S in that entire formula here, we're going to turn it in terms of P and L. So the area of the rectangle is going to be the same as base times height, or P times L. And so the lateral area of any pyramid with a regular polygon base, because half of that rectangle is the triangles themselves, is going to be 1/2 perimeter times slant height, or PL. So then our final step to take our total surface area, S, is to take S and know again that it's the lateral area plus the base. Now, because this is a pyramid, there aren't two bases like there were before. So just L plus B, or the lateral area formula we have, 1/2 perimeter times slant height plus whatever the area of the base is. Does this hold for other pyramids as well? Yes, it works for all the pyramids. The only thing we have to consider is that we just might have more or less of those isosceles triangle pieces on the sides to the base. Okay, so let's do an example. At the top of the next page, you can see the surface area formulas reminded for you there. Please do take note of those and start to commit those to memory. On your next quiz, you'll see a matching section like before. If we zoom in here, example 1, it says find the lateral area and the surface area of each regular pyramid. So our lateral area is going to be 1/2 perimeter times length, because each side there is 5, then 4 times 5 is the perimeter, which is 20, so we can stick that in. And then our lateral height is 9, so we get 90. To find the total surface area, we're going to take the lateral area 90 plus the base 5 squared, add 25 in, and we get 115 square inches. Got a new pyramid here in part B. We're going to find, first of all, we do not have the slant height. Notice what the arrow is drawn to is the height itself. We need that hypotenuse of that right triangle there, or the slant height. So the legs of the right triangle are 5, because it's half of the distance across the pyramid base there, and 12. Now, we know enough about our triples, I hope, by this point to realize that this is a 5, 12, 13 5, 12, 13 right triangle. So that's my lateral height is 13. Let's find first the lateral area. We're going to take half of the perimeter, which is 4 sides of 10 each, so 40, times the lateral height, 13, and we get 260 meters squared. Then to find the surface area, we're going to take that 260 and we're going to add in the base. It's a square with side of 10, is 360. On the next page, these are your on your own questions here for your turn. Please take note of the fact that I have put the answers for you again at the bottom in your copy. Make sure that you check those as we come into class tomorrow. Take a pause here and just make sure that you are organizing your work. It's really important to make sure that you are labeling everything, lateral area, surface area, all the pieces. It's going to be super important, okay? Okay, so we've taken care of pyramids. Now we're going to go ahead and see if we can find the surface area of a cone formula. So we're going to consider if we were to take a circle and a sector of a circle, which is the unrolled, if you will, cone edges there, cone surface. If we were to cut and unroll that, it would be a sector. And so now what we're going to consider is the dimensions there. The dimensions of circle D as the radius is R, circle C is the radius is L, or the slant height. Now we're going to complete a proportion here. Area over area equals arc length over arc length. So we're looking for the arc length. And that's the entire circle. Because notice in the proportion, the sector over the circle, the sector over the circle. So we can put in a formula for the circumference. So we have in the denominator here, the arc length of the whole entire circle is the same thing as the circumference of circle C. So what I know at this point is that the arc length of the sector is equal to the circumference of circle D. So the circumference of circle D is just 2 pi r. And then the circumference of circle C is going to be 2 pi times that radius, which actually is L. And then, of course, we multiply both sides by the area of circle C, which is just pi r squared. And the r in this case, because it's circle C, is the slant height, L. So pi L squared, if you will. Now we're going to simplify. On the right-hand side here, the 2's are going to cancel out, and so are the pi's. And then one of those L's is going to cancel with one of the L's in the factor of L squared. And simplifying completely, we get pi RL. So the lateral area of the cone, the part around the outside of the cone minus the base there, is pi RL. And so our total surface area is going to be the lateral area plus the base, or pi RL, and then plus the area of the base, which is pi r squared. Okay, so moving on, if we're going to find the surface area of a cone, keep in mind those formulas. And we have a couple of examples to go through here. Example 3. Okay, so in example 3, we're going to first find the slant height because we need pi RL plus pi r squared eventually. Our L is just 10 of a 6, 8, 10 based 3, 4, 5 triangle, but you can do Pythagorean theorem to find it if you want to. And then in step 2, we're going to put together the slant height with the radius and pi. We get 60 pi for the lateral area. And then we're going to find the total surface area by taking that 60 pi and adding in the pi r squared, r being 6. So 36 more pi added to 60 pi is 96 pi centimeters squared. And so the hint that I'll give you here, notice we've not had any decimals along the way yet at all. The easiest way to do all of these problems, especially when they involve pi like a cone will for you, is to make sure that you keep your answer in terms of pi for the entire steps of the work that you do until the very last step for yourselves, so that when I turn to the next page, that's when my calculator starts to be used, and I can simply take the total 96 pi centimeters squared that I have, and then on page 1009 you can see now we're using a calculator to take that 96 pi and turn it into 301.6 centimeters squared. All right, so new example, new right triangle here, new piece that's actually missing. This time it's r that we're missing. So I hope you can see here as we fill in Pythagorean theorem. 625 is going to equal r squared plus 576. If we subtract 576 from each side, we get the square root there is 7. So my radius is 7. Substituting into my lateral area formula, I now have R and L, so I get 175 pi. Notice I'm not changing that to a decimal, so we're going to substitute that piece in to find the total surface area. 175 pi plus another pi r squared, or 7 squared, and we get 224 pi. The paper part is 175 pi. That's just the lateral area. So 549.8 with my calculator in the last step. And then the final paper and plastic together is 224 pi, which is going to be 703.9 centimeters squared. I know these units are already drawn in for you each time, but please make sure that you're doing square units. Okay, it's your turn to do an on your own with some cones here. Make sure you check those highlighted answers before we go to our composite figures. Okay, so composite figure, remember, the really biggest thing I can tell you guys to help with this is to keep track of all the different pieces you want to put together here. First, we're going to start by taking the lateral area of the cone, which is the 90, which is the total height, minus the 45, which is the height of the cylinder. To get, first of all, the height of the cone is, using a right triangle with 28, 45 as legs, and plugging into Pythagorean theorem, we need to find the hypotenuse there. So the square root of 28 squared plus 45 squared is going to be 53 using a calculator. If the slant height is 53 and the radius is 28, then we've got 1,484 pi, multiplying that out. Again, keeping it in terms of pi. Now we're going to find the lateral area of the cylinder. And we're going to go ahead and we're going to add in 2 pi r h to that. Again, radius is 28. Height of the cylinder is 45, so 2,520 pi. And then the last piece we need to add in is that base of the cylinder with pi r squared. We get 784 centimeters squared. Add all those three pieces. Just wanted to remind you that when we get 15,041.9, notice your book did not put any decimals in until the last step. Part B of example 4. This time we have a prism, which is actually a cube, and then a pyramid carved right out of it. So thinking about composite here, eventually we're going to need to add in extra surface area, because remember the volume subtracted means actually more surface area is being painted. So I first need to find the slant height of the pyramid. And the sides there are 1 and 2, the legs of that right triangle. So we get the square root of 5 for the slant height of the pyramid. Now we're going to find the lateral area of the pyramid, which is the perimeter of the prism or cube, which is 8, times the slant height, which is square root of 5, and then half of that, remember, because we're doing pyramids, so they're triangles, so 4 radical 5. Then we're going to find the lateral area of the prism, which is 8 times 2, or 16. And then for the composite figure, remember, we're going to take the painted surface of the inside pyramid, 4 radical 5, plus the painted surface on the outside lateral area of the prism, 16. And then don't forget we'd have to paint the base as well, which is 4, 2 times 2. And when we simplify that, we get 28.9. So as always, you guys, with your on your owns here, make sure you're paying attention to the highlighted answers for you. The composites are going to get a little trickier, but you can do it. I have faith in you. Best thing I can tell you is to make sure that you stay organized in your work. If the area provided in this whisk form is not enough, then give yourself more room. You guys can do this. Just stay organized, and we'll check in with you tomorrow.